Okay, welcome everyone. I think we'll get started. As you can see on your screen, hopefully this is the Green Business Fund technical webinar on refrigeration. I'm your host through this webinar, David Tobin. I'm a chartered engineer and energy consultant with the Carbon Trust. Spend a lot of my time out conducting energy audits and providing energy consultancy to people and organisations within private public sectors, and here to talk to you today about refrigeration, something we see on a very several initial webinars we've ran through the Carbon Trust as part of the Green Business Fund. Others include HVAC, motors and drives, lighting, compressed air. If you'd like to review any of those, they're available on our website, the Green Business Fund website, the Carbon Trust. Today we're talking about refrigeration. This is an overview of the agenda we're looking to cover. It's important to understand this is aimed at all levels of understanding, so we'll be speaking in quite broad terms on refrigeration. So if you do want more detail, please do feed that back. We're trying to allow this to help everybody and to be understood by everybody. First, a quick introduction for those of you who are less familiar with the Carbon Trust. We've been around since 2001. We're a not-for-profit organisation. We're mission-driven, and we're independent experts on carbon reduction and resource efficiency. The work we do falls into three broad areas: advice, we provide to businesses, governments, public sector; footprinting for organisations, products and services, and technology, where we help to develop and deploy low carbon technologies and solutions. The advice we provide under the Green Business Fund falls very much into the advice area of this business. It's part of the business I work in myself. So a quick introduction, just to make sure that you are on the webinar you want to be on. So the aim of the webinar is to improve the understanding of refrigeration generally and the typical types of system, develop understanding of how improved controls, management practices or technology can deliver cost-effective energy savings, understanding the importance of good maintenance, which again falls into the one above as well, using case study examples where we can to illustrate the saving potential for optimizing refrigeration systems, and ultimately describe how the Green Business Fund, among other schemes, can help. So before we move into detail, it's worth considering having a think about why refrigeration is important. And for some sectors in particular, this is a particularly important consideration for their energy consumption. You can see there from some of our research proportions of energy costs that may be accounted for by refrigeration. And if you're operating in sectors like cold storage, supermarkets, small shops, it's a substantial underlying cost to operate in the business. And so even a small reduction in refrigeration energy use can offer significant cost savings, ultimately resulting in increased profits, which every business is striving for. Energy saving with refrigeration is often easier when you have a good understanding of it and its functionality at the most basic level. So again, this is us looking to deliver this to all levels of understanding. So at very basic terms, what is refrigeration? So it's essentially a process in which work is done to move heat from one location to another. This often starts at the low temperature reservoir, which would be your cold store or your fridge. Work is then done to move that thermal energy to the high temperature reservoir, which is often located outside the building. Now, there are various types of refrigeration system to suit a wide range of cooling needs in commerce and industry. By far the most common is the vapor compression cycle, which you can see the common elements of here. This is the process, again, of moving heat from internal to external. So we'll start inside your cold room or fridge freezer, where a low pressure liquid refrigerant in an evaporator absorbs heat, evaporates, into a refrigerant, from the refrigerant to a gas, and this is collecting heat. And to improve the efficiency of this process, you really want to make it as easy as possible to collect that heat. And it's important to remember that pressure and temperature are proportional during this cycle. So this is the start point for moving the heat from internal to external. The next step, now that we've collected that heat from inside the cold store, that superheated vapor passes to the compressor where the pressure is raised, and as a result the temperature of the gas is raised further. And this is the real energy intensive part of the process, so reducing the work of this system is often the focus of energy saving initiatives. It often work to raise the refrigerant temperature above the external ambient so that we can move on to actually rejecting that heat externally. So the high pressure superheated refrigerant vapor is then passed to the condenser, where it is cooled typically by air or water, rejecting that latent heat as it goes back to a liquid refrigerant. Again, often the refrigerant is passed to the condenser higher temperature than the external ambient to make it easier to reject that heat. And finally, before the refrigerant goes back into the evaporator, it passes through an expansion valve where the pressure is reduced as a liquid to return to a temperature back that is lower, entering the evaporator, and again will allow, once it enters the evaporator, the refrigerant to evaporate again. This is a simple system, but it works. You need to know what you can do at each element to make it easier to do the work it needs to do to move the heat from internal to external. So what are the typical elements we see, and what do they look like in a refrigeration system? So on the low pressure side with the evaporators, we have typically air coolers, so there'll be walk-in cold rooms or freezers, or display cabinets in a retail environment, open fridges in other retail environments, or to cool liquid. This is often via plate heat exchangers in industrial processes. On the high pressure side, which is where we reject the heat, we have the condensers. These all deposit heat to the local environment. Air-cooled condensers are most common. They simply blow air over the refrigerant to cool and condense it. Evaporative condensers are typically for larger systems and use evaporation of water to aid the cooling process. And then there's water-cooled systems, which are used in some larger systems, usually in conjunction with cooling towers in the industrial environment. Other key refrigeration elements that you will see within a refrigeration system, you see compressors on the left here. They can include scroll, reciprocating, and screw type. You can see it in the images, and they're often installed in multiples to improve the part load operation, as they're more efficient when they're operating fully loaded. You can also see expansion devices. They're often just valves with very little energy consumption, if any, in part of the cycle. You'll often find these packaged together in chillers in both industrial and commercial situations. These are often used to produce chilled water, glycol, or any other chilled fluid for the process or air conditioning equipment. They're often factory assembled and self-contained units, which include the compressors, the controls, the evaporator. And the condensers can be inbuilt, or they can be installed remotely. They're often chosen to meet the maximum cooling load during the warmest weather. However, for most of the year, the chiller will not be running on these conditions. The load will be smaller, the weather will be cooler, and we'll speak more on the opportunities that this presents later in the presentation. So, what are the typical energy saving opportunities that are available for each of these types of system, or elements of the system? First thing to point out is that you don't necessarily need to invest significant capital to make savings. There are some good housekeeping and maintenance measures that can really have a significant impact on the energy consumption of these system elements. However, there are clearly significant savings available through investment, and we'll look to cover both maintenance, good housekeeping, and investment measures for each of these key areas are listed here on the right, and these are the key systems we're going to look at through the remainder of this webinar. So we'll start with display cabinets. This is primarily aimed at the retail environment, so apologies if you're not operating in that sector. But for retail, they are a heavy energy user. So in terms of good housekeeping, don't overstock them. Make sure your cabinet and air grills are clear of product and merchandising. A properly stocked cabinet will maintain the optimum food temperatures with a minimum energy consumption. Make sure your product is loaded into your cabinets and hasn't warmed in transfer, being left in ambient conditions. Use night blinds where they're fitted. Make sure you pull them down of an evening when you shut up shop. Switch off the lights and anti-condensation heaters, and check defrost settings are appropriate to match the conditions and avoid unnecessary heating. In terms of maintenance and low cost measures, use a good cleaning and maintenance schedule. This will maintain top efficiency and good temperature control. Use well-fitting night blinds and covers. Often you'll see there's significant gaps which will be hindering their performance. Ensure all trim and anti-sweat heaters are pulsed or switched off automatically when not needed. And think about fitting anti-mist film or spray, or switching off heaters permanently. Ensure expansion valves are fitted or appropriately commissioned. Use electronic types where possible, and use defrost and temperature cutout to avoid unnecessary heating. If you're using electric defrosting on a chill cabinet, and check whether you need it. Natural or on-off defrost cycle might be an option. In terms of investment measures, you can see here on the right some of the impacts that various measures will have, but high efficiency LED canopy lighting is one that's very common and easy to implement. You can consider fitting transparent doors to open the cabinets. This is obviously, it can hinder the user experience in terms of the accessing the products on the cabinet, but it does have a significant impact in terms of the energy consumption. And if you're considering keeping the cabinets for at least 5 years, look at replacing lights and fans with lower power alternatives. So cold rooms, these are found very commonly in retail, catering establishments, or cold storage environments where you keep produce. In terms of good housekeeping measures, door management is critical, and it's something that you should encourage your staff to be aware of the impacts that they're having in terms of the energy consumption of your cold store. You can see on the diagram just how much ingress can happen through the doors of a cold store. The idea is to keep warm air and moisture out and keep the energy costs down. Make sure that airflow from evaporators isn't obstructed. If they're frosted, if they're blocked by produce, they're having to work harder to collect heat. Run your cold store at the highest possible temperature for the product. Talk to your suppliers about the temperature the products can be stored at, and adjust your temperatures accordingly. And try and get them as high as possible so that you're not doing more work than you need to. Ensure the product hasn't warmed in transfer to the cold room, so it picks up temperature, making your cold room have to work harder. And switch off your lighting in the cold room when it's not in use. You can fit automated sensors to control that, and make sure that you use as little lighting as possible. In terms of maintenance, to repair any damaged door seals, if there are gaps around your door, then you will be constantly letting heat into the cold store, causing it to work harder. If you have got strip curtains installed, make sure they're maintained. Very, very common is that we see strip curtains with gaps or held backs for easy access. This will be costing you money in terms of energy, so do ensure that your strip curtains are fitted effectively. Upgrade lighting to LED. Again, LED performs very well in a cold environment, So it's a good efficiency measure to implement, particularly if your cold room is occupied for long periods. And maintain and repair wall panel seals and make sure that they are as well insulated as can possibly be. For investment measures, particularly if you have a large amount of traffic, automatic and rapid closed doors should be fitted to reduce that ingress of warm, moist air. Installing defrost on demand systems is critical to ensure your evaporator efficiency. And for larger stores where you have access by forklifts, a dehumidifying airlock stops the forklift bringing in warm, moist air, which again increases the work of the system. For new stores, consider sliding doors. They have a better seals and are less prone to damage through use by members of staff. So move on to compressors. Now these are this is where the real heavy work is done in the refrigeration system, and this will have the biggest impact if you're able to make their life easier and reduce the work that the compressor is doing. Remember, it's working to raise pressure and hence temperature above ambient so they can reject heat externally. So one thing to make sure when your system is being maintained, installed, commissioned, get your technician to set the condensing temperature to the lowest practical level via head pressure controls. And once this limit is reached, it may be possible to upgrade control valves or condensing capacity to allow further reduction. But ultimately, if you can get this lower, so for every you can see down at the bottom that for every degree that temperature lift is reduced, you'll save around 4% of the compressor energy for a chilled temperature system, or 2% for a low temperature system. So it can have a significant impact if you can make a few degrees reduction in condensing temperature. And on multi-compressor systems, make sure that the compressor suction pressure is set only as low as required. Often winter set point can be higher than in summer. So again, that's something to check with your maintenance or commissioning technician. In terms of investment measures, if you're unable to reduce condensing temperature for any reasons, then liquid pressure amplification can be used. This is typically something that can be applied to larger systems and typical savings. We're talking sort of 300 kilowatt size, and savings can be up to 25% for those types of installations. And if cooling load varies substantially, consider speed controls on one or more of your compressors to enable you to modulate them effectively and reduce the consumption. But you can see here what the impact can have. If you have a fixed condensing temperature of 40 degrees in the graph, then you'll continue to use a higher level of consumption of energy. But if you set a float of about 20 degrees above ambient, then when weather allows, between 25 and 35% saving can be made for a chilled temperature system by having it just float above 20 degrees above the external daily temperature. So it's well worth getting your technicians to look at that. Moving on to condensers. The aim with condensers is making it as easy as possible to reject that heat. The compressors put the work in to raise that temperature to a level that it can be easily rejected. So make it as easy as possible on the external condenser for that system to reject the heat. So keep them, if they're outside, located often around the back of your building, sometimes hard to reach places, but make sure they're clear of leaves, litter, vegetation. If they're dirty or blocked, they're costing you money. So get them cleaned. Have the condenser fins and filters professionally cleaned regularly, and check all fans are operational and operating effectively. Be aware that some fans might not be switched on because of your modulating controls and the variability of the heat rejection, but it's worth ensuring that on full load all the fans are operating. If you are to make investment measures, or if you are in a particularly dirty environment, or they are located in a particularly dirty environment, installing removable condenser screens to prevent dirt and blockage is an option. Installing additional condensers is also an option if they are struggling to reject heat effectively at peak times. If they're able to reject heat effectively, then it reduces the work on the compressor and the other energy intensive parts of the system. You can also look to replace the condenser fans with high efficiency electrically commutated alternatives which have lower energy consumption than sort of AC standard models. If you are looking at purchasing or designing a new system, get as big a condenser as you possibly can so that you have a substantial amount of heat rejection capability. Again, this is reducing the effort that the compressor will need to make. So increasing the condenser size by 30%, it can save you up to 10% of its energy use. So again, if we're able to help it reject heat, the system will, as a whole, will operate more efficiently. So moving on to evaporators. So these are collecting heat. Even in very cold environments, there's heat there to collect. So make it as easy as possible for them to collect that heat. So if you see ice, something is wrong. It means you need to look at your defrost settings. Switch off evaporators in any cold rooms that are not in use. And if possible, locate the room thermostat as high as you can without compromising the food or process. Again, obviously heat rises. So, and again, increasing the thermostat's temperature to the highest level we possibly can make savings. So a 1% increase could reduce your energy use by up to 2%. In terms of maintenance, clean the evaporator cores very regularly, check all fans are functioning correctly. Evaporator drains, the evaporator won't work effectively, it can't drain moisture away, so make sure they're properly insulated so they don't freeze and block. And also install defrost on demand systems for freezer cabinets, and this can have up to 9% effect on your energy consumption. So, as we've discussed, the aim of a refrigeration system is to move heat from one location to another, often just dumping it externally. And for some systems, particularly larger systems, this can result in quite a significant amount of dumped, wasted thermal energy. So there are ways that you can look to recover that energy. Typically, the energy or thermal energy that is rejected by a refrigeration system comes as a sort of high grade, what is called high grade or low grade heat, which basically refers to its temperature. The high grade heat could account for around 10% of the heat that's dumped, and this could be 50, 60 degrees, often occurs just after the compressor, where you have the highest temperature of the refrigerant. This could be used as it's 50, 60 degrees to support hot water systems, any processes you have. Boiler feed water could be used for this, or also can benefit from the low grade heat where the remainder of the heat ends up. So this could be between 20 and 30 degrees C. Again, this could be used for preheating of things like hot water. Could connect to ventilation systems in order to support thermal energy demand. Or you could directly collect air rejected from condensers, again to duct it into a factory or warehouse to heat the space. So there are various ways in which you can recover the heat of a refrigeration system, and it's worth investigating, particularly if you have a need for refrigeration, but also a need for thermal processes on your site. Now, reducing leaks. If this isn't part of your maintenance regime, I'd advise you to make it so, as it isn't just harmful to the environment, it is costing you money. You can see there, based on the size of the system and the capacity of refrigerant, just how regularly a system should be checked for leaks. So most refrigeration systems have some leakage. Annual leakage rate of 20% in the UK is reasonably common, and a typical system, this would mean a loss in around 11% of its efficiency. and so a direct increase in energy costs. And for larger systems in particular, you should look to have permanent leak detection systems in place to make sure that you're minimizing refrigerant leakage as much as possible. Free cooling, we've discussed this earlier, and really it's looking at increasing the condensing temperature during external ambient conditions. So during times when external ambient conditions are cold enough, and there might not be a lot of work for the compressor at all. And we've kind of given an example here. In the UK environment is well suited to this. Average UK temperature is below 9 degrees C, and it's below 5 degrees C for around 3 months each year. So a lot of air conditioning, a lot of process refrigeration systems can benefit from this and reduce the actual workload and have effectively free cooling. So the example case study that's given here, so a manufacturer is using chillers to deliver chilled water at 4 degrees C to a process for which the water only needed to be 16 degrees C. The temperature of the chillers could not be raised because the process, another process, required chilled water at 4 degrees C. So the company installed a free cooler that would produce 16 degrees C water for at least 200 days of the year using just fans, so no compressors involved. And you can see there that the effect, where it was costing around £118 per day to create that chilled water, that had dropped to £21 per day with the new system, saving £19,000 per year. So the cost of the free cooler was about £45,000, and this paid back in less than 2.5 years. So it's an example there of how a free cooling system, particularly if you only require higher temperature chilled water or cooling, can benefit from the UK's cooler ambient environment. Now, chillers are the package units we mentioned earlier that can contain evaporators, compressors, expansion valves, and condensers, often selected for the full load required on the chiller, which may be correct depending on requirements. However, with, as I said, the variable load and the UK's relatively cool environment, most of the time the chiller is likely to be on part load. So make sure you choose a chiller with good part load performance, even possibly free cooling to make the most of the UK's relatively cool environment. Most manufacturers will offer something like this. You can see there at the graph on the right comparing chiller A and B. Chiller A, you can see that although the energy efficiency ratio of the system improves slightly from the orange line, sorry, I've got those around. So chiller B, you see the system improves only slightly between summer and winter, whereas chiller A, the seasonal efficiency jumps substantially between the two. It comes with a cost premium, but often that's recovered very quickly with energy saving and the use of the system. Installation. This is a slow burner. It will cost you a lot potentially in the long run. It's often very apparent when it's missing, particularly on lower temperature systems where you can see frost buildup. Thermal imaging from your refrigeration engineer may have the ability to identify where there are gaps in refrigeration, but be generous with it. Install a good thickness and install it to last the lifetime of the equipment to 15 to 25 years. Don't just try and install the minimum. Ensure it's properly sealed at the joints, and you can see here an example of the losses. So if the chilled water system is operating with flow temperature of 7 degrees C, return temperature of 12 degrees C, and these are the temperatures at the chiller. The supply temperature is measured at the end of the pipework, and the cooling load is increased by just half a degree through the pipework run. That's heat that's been gained without any useful cooling being done, and a similar heat gain will be experienced on the return line. So the total heat gain is only around 0.75 degrees C, but that's effectively 15% of the system cooling capacity. And if the deterioration of the insulation is severe, the losses can be higher, up to 25%. So it's well worth making sure that you have the proper insulation on your refrigeration systems. maintenance now, I think we've mentioned these for most of the systems already. The talk with your maintenance provider. If they're not undertaking the activities listed here, I would question why not. Don't let them get away with minimum compliance checks. Do undertake these detailed maintenance measures to make sure that they are optimizing the efficiency of the system. As you can see here, you can reduce your energy costs by 50% or more by making sure that your refrigeration plant is well operated and maintained. So this is really just a checklist to refer to with your maintenance providers to make sure that they're doing all they can to optimize your systems. And again, I would suggest asking your maintenance contractor what monitoring you have available and how it can be improved. Pressure sensors to monitor system pressures are beneficial even on smaller systems. Drops in suction pressures could indicate problems such as refrigerant leaks. We've highlighted the issue that can cause. Temperature controls, effective monitoring, again, as we've outlined earlier, of internal temperatures in the cold store or ambient temperature will allow you to observe whether space is being overcooled and if the energy consumption of the system is effectively modulating. Given here an example of a small supermarket that had a clear display temperature on all units, which were defrosting, which is an improvement. So you've got the small image on the left there. This highlights all of the temperatures and units that are defrosting out on the retail site, it's a step change and an improvement from the standard small temperature readouts that you get on individual refrigeration units, commonly seen in retail environments. So in terms of other considerations, something to be aware of is F-gas regulations. This may be something that, again, your maintenance provider will have mentioned. There is a big change this year in F-gas regulations. They were introduced as an EU regulation to reduce F-gas emissions by 79%. So these are your refrigerant gases by 79% between 2015 and 2030. And the way that that's being done is the quantity of HFCs available on the EU market is being cut in stages. There's been small cuts to date of 7%, but this year sees a massive cut of around 40%. By 2030, only 20% the quantity of HFCs sold in 2015 will be available. So the result of this is likely to be a potential for price increase of these higher global warming potential refrigerants. You can see here a list in the table, just exactly what those refrigerants are, and they are quite common ones. So these are shown in terms of their GWP, global warming potential weighting. So R404A, R410A, both extremely common refrigerants in air conditioning, in refrigeration, and you can see there that R404A in particular has very high global warming potential. So again, it'd be a case of speaking to your refrigeration maintenance providers or equipment suppliers and making sure that you're able to be future-proofed against these potential high prices for these higher GWP refrigerants in the future, very near future. Often shifting to refrigerants, there are options for converting existing systems to R32. So again, this is something to discuss because it is going to be something that does impact your maintenance, does impact the purchase of new equipment or replacement equipment. So something very much worth considering. A few case studies. This is for a large supermarket chain we have worked with. And this just demonstrates what they've achieved with some of their sort of small to medium convenience stores. What you can see on the little table on the right-hand side is the kilowatt hour per meter squared per floor area of their older sites, where you can see on the on the table there that they haven't implemented many efficiency measures, just the kilowatt hour consumption per meter squared in that store. And you can see that on their retrofitted sites, just the step change that was achieved by retrofitting these various elements. We're talking cleaning and maintenance, recommissioning, which is both something that hopefully you're doing anyway, but LED lights, EC fans, strip curtains, anti-sweat controls, added doors to chiller cabinets, pipe insulation, head pressure control, all the things we've mentioned during this presentation have had a massive impact and brought it down to 746 kilowatt hours per meter squared within their store, which is very close to their brand new store efficiency. So it can be achieved on existing sites. And this gives a case study of a Green Business Fund customer. So it's a butcher on the south coast, had persistent issues with ice build-up on evaporators in cold stores, installed intelligent defrost on-demand systems to help avoid this ice build-up, resulted in more effective heat collection at the evaporator, saving £2,500 per annum in energy costs. Supply of the new controls was determined to be £9,000, a simple payback of just over 3.5 years. However, we're able to contribute to this via the Green Business Fund, and replacement cost was reduced to £7,650, reducing the payback to just 3 years. So again, a good example of an effective efficiency measure well implemented. Which brings us to the Green Business Fund and how it can potentially help. So firstly, what is the Green Business Fund? It's a scheme operated by the Carbon Trust to contribute to improved sustainability and energy efficiency. It currently serves small to medium-sized businesses in England, Scotland and Wales. Provides a combination of advice, training, direct contribution for capital equipment. There's scope for the fund to expand both UK and internationally, should additional funding be made available. It's important to point out that it's while funds last. Current predictions are to run to the end of 2018, but there's potential to extend this. But it is a finite pot on a first come, first served basis. If you haven't yet participated, I'd encourage you to take action. So just again to highlight where the GBF services are available, so England, Scotland and Wales. Who's eligible for the GBF services? So SMEs, schools, sole traders and charities. Domestic properties, public sector and new builds aren't. And you can see here that the exact criteria by which the Green Business Fund defines an SME, so it's worth checking those before looking to apply. We can assist with refurbishments, but only for the energy saving elements of the project. So that's also something worth bearing in mind. So in terms of the services that are offered and that you can avail of as part of the Green Business Fund, so there are local workshops. You can see there the next two, one in Alton, one in Eastleigh. These do move around the country, so it's worth checking the Green Business Fund website to make sure that you can find one, the next one near you. And the 2-hour workshops are hosted by the Carbon Trust partners, but delivered by the Carbon Trust, just to help you understand energy consumption, energy management, typically for companies with less than 50 employees, and we've trained over 135 companies so far. The next service that you can avail of is the opportunity assessment, and this is a bit like an energy audit, effectively. If you want help identifying energy efficiency opportunities, then this is the service for you. There'll be, and depending on the size of your organisation, there'll be a remote or an on-site assessment, again delivered by a Carbon Trust engineer, someone like myself, and will provide you with recommendations on how to reduce the energy consumption on your site, and that's available for SMEs in qualifying geographies. And we've given a case study here of a metal pressing company who were able to implement energy efficiency recommendations based on the findings of an opportunity assessment. So again, something to avail of if it's of interest. So if you do want to actually then implement an energy efficiency recommendation, we're able to offer an implementation advice service. So this is up to 5 days funded support. The Carbon Trust consultant will help you give you assistance with the implementation of the energy efficiency scheme. And typically that involves helping you pull together tender packs, identifying appropriate contractors from our Green Business Directory, issuing those tender packs, helping manage the tender process, and then providing an impartial expert advice on the tender returns to give you the confidence to invest in the energy efficiency measure. Again, this is an example here of a sports hall lighting conversion to LED that we helped implement through this part of the scheme. This is the only part of the scheme that is aimed at non-large companies, so you don't have to be an SME to avail of this. You can have up to 1,000 employees as long as you're situated in the qualifying geographies. And with the final part is the capital contribution, which is it's a non-refundable capital contribution of 15% for projects with a payback of less than 5 years. It's a straightforward process of getting a quotation from the accredited supplier. There'll be some financial verification and identity checks carried out and a technical assessment to confirm the project particulars by one of our team of engineers, but ultimately we can contribute up to 15% of the capital costs of the projects. Projects with a payback greater than 5 years are awarded a contribution, but it's based then on contribution of 15% of 5 times the annual energy savings. That's sort of prorated based on saving capacity of the project. So that's it with the Green Business Fund, but there are other schemes that are potentially available. So there are interest-free loans available, and they're designed to support businesses upgrading to more energy efficient equipment and renewables. So you can see there's building technologies, there's industrial process technologies, of which refrigeration is one, and renewables. The loans are interest free and are available in Wales and Northern Ireland. For Welsh SMEs, could borrow £300,000 to £200,000, and Northern Ireland businesses of all sizes can borrow £300,000 to £400,000. And the loan is offered based on the carbon saving project can deliver. So it's £1,000 for every 1.5 tons of carbon dioxide that can be saved annually. The loans are designed so that in most cases, monthly repayment amount will be similar to the reduction in the customer's monthly energy bill. The savings are sense checked by engineers to provide assurance that they can be achieved, and loans are interest-free, unsecured, and have no setup fees. Businesses in Wales are very lucky. They can apply for both interest-free loans and Green Business Fund capital contribution, which again will fund up to £5,000 of the total project cost. If you want more information on those, then more information is available via those links provided. And lastly, there's the energy technology list. So this is something that the Carbon Trust helps manage. And if you're making plant upgrades, make sure that you select equipment from this list, because it allows you to, for organisations that pay income or corporation tax, you can claim enhanced capital allowance on the purchase of the the ETL listed equipment, which means that you can get all the tax benefit in the year of purchase. So the example here is the benefit to an organisation spending £10,000 on ETL equipment, give you around £2,000. And again, if you have more questions on this, then more information is available on our website provided or via the email address if you have particular direct questions you'd like answered. Otherwise, thank you everyone for attending the webinar. If you do have any questions post this, then please do send them across to greenbusiness at carbontrust.com, or feel free to dial 020 7832 4773